Our project name is Smart Saviour Device to Avoid Death Due to Drowning in Swimming Pools. My name is Divya Sinha.
And I'm Deepika.
Our project ID is PROJ_GEN_4.
If life were predictable, it would cease to be life and be without flavor.
With this code, we would like to move on to a small story where a girl who almost drowned herself explained her experience.
She explained the horrific experience and how it felt like while drowning, and the stages human faces during drowning.
Fortunately, she survived this accident, but there are many who doesn't, and who survives definitely live their life with a lot of mental trauma and other effects.
Her experience during first 3 seconds were as follows. My body began to float upwards. My mouth was open and my throat completely contracted. My body was wrapped in an awkward posture. My torso was arched forward, my limbs were flowing backward, and my eyes were gazing straight up, although I couldn't register anything I was seeing.
After the 3 seconds passed, I began to desperately feel my arms and legs, and my head had two simultaneous continuous thoughts exhale very, very small amounts of air. My mouth was open and I was letting out discrete, minuscule amount of air through my esophagus, trying to buy as much time as I could before I ran out of air. I could feel my flailing slowly take over my body upwards. I had to survive. I had to somehow reach the surface. I didn't want to die.
More seconds elapsed. I was running out of air. I tried to look up to see sunlight, but I saw none. It dawned on me that I wouldn't make it. I let out another breath of air, this one more copious than the others. My body went limp and my mind went blank, and I gave up on all effort. I just let go, and my flaccid body just floated in the water for a few seconds. My lungs had more or less given out, and there was no pain, just comfort.
Side effects which are seen on people and kids who have been in the same situation as described in the story: inability to swim, panicking, brain hypoxia.
It is a condition where brain isn't getting enough oxygen. This can occur when someone is drowning, choking, suffocating, or in cardiac arrest. Brain injury, stroke, or other possible causes of brain hypoxia.
Brain ischemia.
It is a condition in which there is insufficient blood flow to the brain to meet metabolic demands. This leads to poor oxygen supply or cerebral hypoxia, and thus leads to the death of brain tissue or cerebral infarction.
And hydrophobic. And of course, nobody can explain the pain of the families who have lost their loved ones who got drowned in the swimming pools. Now we'll look into some statistics.
As stated by imgo.com, on an average 3,536 people die annually due to drowning.
Drowning is the number one cause of unintentional death for children between the age of 1 and 4.
Almost 73% non-fatal swimming pool injuries involve children younger than 5 years old.
67% of swimming pool drowning deaths involve children younger than 3 years old. These are the graph illustrating the deaths in the swimming pools by CDC and IMBD data. From the drastic statistics, we have come to a problem statement. As all of us know, the life is the most precious thing in this world, and there are many people who lose their life while drowning in the swimming pool.
In a year, almost 4,000 people death takes place, according to statistics. This death rate includes children too. So this was the problem statement like how to avoid deaths in swimming pools. And we have proposed a solution for it, and it is explained in further slides.
For in dream we enter a world entirely our own, let them swim in the deepest ocean, or glide over the highest cloud. With this code, we'll move forward to our next slides. First one being objectives. To overcome the problem of drowning in the swimming pool and avoid accidental deaths.
The main aim of our project is to provide a life saving device or gadget for kids and people.
Now we'll look into the abstract. As mentioned earlier, objective of this project is to overcome the problem and give a solution to it so that deaths can be avoided in the swimming pools.
There will always be some unfaithful times while swimming because during emergency situations, sometimes lifeguards may not be present at the spot and there will be no help offered to the people in case if they are in need. Especially children of younger ages faces a lot of problem due to helplessness.
When a person is drowning, the first response of their action is panic.
For a person, it almost takes 30 to 60 seconds of time to get completely submerged in the water, and due to fear of getting drowned, they get panic attack and some other breathing issues which may harm their health.
Once a person starts drowning, they start panicking, and as panic increases, the pulse rate drastically increases, and hence pulse rate can be measured.
So basically, our prototype will measure the pulse rate and send the emergency signals to the authorities.
Now we'll look into the methodology. In the proposed project, we are going to design and develop a prototype which can be developed into wristband, which will measure the pulse rate of the person wearing it.
The variations in pulse rate can be detected by the sensor, and this pulse rate can be measured to detect whether he or she is drowning. A certain pulse rate threshold will be set initially.
Buzzers or alarms can be used which will give signals to authorities about emergency situations, and a LCD display can be placed to indicate the emergency. We can also put GPS on it so that we can locate the person who's wearing it.
So let us look onto the block diagram of a project. So basically the prototype which we have developed can be used to sense the pulse from the pulse rate detector. A certain threshold will be set in advance. In case if the person's pulse rate exceeds or varies within the range, they can be indicated to the authority by using alarms or buzzers, and it can be displayed through LEDs or LCDs. And to track the position of the person who is drowning, GPS can also be used.
Now we'll look into working of the project. Pulse rate detector will detect the pulse signal from human wrist and convert it to digital signal. That digital signal will be fed in microcontroller. In the microcontroller, the comparison of the signal will take place with threshold which will be set. If the pulse rate is within the range, there will be no output, hence indicating no emergency. But if the pulse rate exceeds the range of threshold, it will give emergency signal in the form of LED and buzzer. And we can even incorporate other components like Wi-Fi connections to connect to a cloud and store the data. List of hardware and softwares.
So the hardware used are pulse rate sensor SCN11574, Arduino Uno, USB cable, Wi-Fi module ESP8266, LEDs, buzzer, jumper wires and breadboard.
Software used are Arduino IDE and ThinkSpeak. Results and discussion. Our project outcome will be a prototype which will help to save lives of adults and kids who get stuck in some unfortunate situations, and we can save a precious life.
Our device will be certainly helpful as it is a life-saving device and it is cost-effective.
Our device can be used in entertainment industry, especially in the area where water bodies are used or where swimming pools are provided for the public. Examples: Innovative Film City Wonderla and many more. Societal relevance. The accidental deaths will have direct impact on society and family and leads to various problems, and these problems lead to various drastic outcomes.
Problem comes in account when the entertainment industries, institutions, and clubs do not provide a good safety measures to the people who will use the facility. Improper safety or no safety measures leads to accidental deaths.
When accidental deaths happen, the reputation of the institutions and clubs gets affected, and in major cases, they even get shut down.
Lives of many people get affected due to this.
Our project will reduce these problems and help these industries and institutions to function without any loss and, of course, any effect of the life of the kids and adults. Conclusion and future scope. Our prototype will help a lot of people in our society to overcome their fear of getting drowned and will encourage them to learn a skill which is very much important to know in our day to day life because no one knows what is waiting for us in the future.
Even the professional swimmers who already know swimming can also use this as a safety device. There are times when, due to lack of salt and water in the body, people feel weak and start getting cramps, due to which the limb stops working. And in such situation, even a well-trained swimmer can drown.
There is a very good example for this statement. In swimming Olympics competition, there is always lifeguards present. You may think, what a irony! A swimming competition which itself means that whoever is competing are well trained, then why lifeguards? Well, the answer is simple.
Even well-trained people can sometimes meet unfortunate times due to muscle cramps and the body can stop working. So in such situations, they need help. And in this kind of situations, our prototype can be a great help.
There are a lot of schools where the swimming classes are provided, and with few teachers around, looking out for so many kids is difficult. In such cases, school can use this device for the safety measures by providing each student a device.
Same goes for the entertainment industries where they provide water games and even provide the swimming pools for the people to enjoy. In these area also, our project works as a safety device.
In the future, with implementation of other devices, we can use this device in the other areas also, like beaches and surfing competitions, which are held in many places.
For the accuracy of the device, we can add more sensors and devices such as GPS for future implementations.
Commercialization of the project and targeted users. Need is very important. People buy devices and products only when they need them. Our device, which works as a safety device, is appropriate to fulfill that need.
Apart from need, our device is a life-saving gadget, which is uttermost important thing. Who doesn't want their life to be safe and still can enjoy all the aspects of life, which definitely includes swimming as one.
The targeted users of our device will definitely be the children of the schools and colleges, people who go to entertainment area like water parks.
People who enjoy swimming can also use our device as a safety measure.
People and kids who are learning how to swim can use our device. Thank you.
Thank you.
Now, let us look on to the description of the hardware components used in a project. First one is pulse rate sensor SCN11574. Pulse rate sensor is used to sense the pulse rate and give digital output. It works on the principle of the light modulation by blood flow through veins, pulse and fingers. It essentially combines a simple optical heart rate sensor with amplification and noise modulation circuitry to make it fast and easy to get reliable pulse readings. Next, USB cable. A USB port is a standard cable connection interface for personal computers and consumer electronic devices. Next, Arduino Uno. The Arduino Uno is an open source microcontroller board based on the microchip Atmega 328P microcontroller and is developed by Arduino CC. The board is equipped with digital and analog input-output pins, and it can be interfaced to various compatible boards and other electronic devices. The Arduino board consists of 14 digital input-output pins and 6 analog input-output pins, and it is programmed with Arduino IDE. Next, the Wi-Fi module ESP8266. The ESP8266 Wi-Fi module is a self-contained SoC with integrated TCP/IP protocol stack that can give microcontroller access to the given Wi-Fi network. Next, breadboard. A breadboard is a construction base for prototyping of electronics. Breadboards are used to help you connect various components to form a basic circuit. Buzzer. A buzzer or a beeper is an audio signaling device which may be mechanical, electromechanical or piezoelectric. Now, let us look on to the software components used in our project and their description. First one is Arduino IDE. Arduino Integrated Development Environment is a cross-platform application that is written in function from C and C++. It helps you to write the program and upload the programs to various Arduino compatible boards with the help of a third-party code. Next software used is ThinkSpeak. ThinkSpeak is an IoT analytic platform service that allows you to aggregate, visualize and analyze the live data streams in the cloud. ThinkSpeak is also used for prototyping and proof concepts of IoT systems using analytics. ThinkSpeak is an IoT analytic platform service that allows you to aggregate, visualize and analyze the live data streams in the cloud. ThinkSpeak is also used for prototyping and proof concepts of IoT systems using analytics.
Now we will look into the working of the project. First we will see the connections done in the circuits. So this is our microcontroller Arduino Uno, which is an open source platform based on easy to use hardware and software. Arduino boards are able to read inputs, light on a sensor, a finger on a button or a Twitter message and turn it on an LED, publishing something online. We can even tell board what to do by sending a set of instructions to the microcontroller on a board. To do so, we use Arduino programming language and the Arduino software IDE. So why did we use Arduino for our project? Even though a lot of microcontrollers are present in the market, well, there are a lot of reasons for using Arduino. Among them, few are: Arduinos are inexpensive. They provide cross-platform. The Arduino software runs on Windows and Linux operating systems as well. Most of the microcontroller systems are limited to Windows. It provides simple and clear programming environment. It is an open source and extensible software and hardware. Now we will look into technical specification of Arduino Uno. Arduino Uno contains ATmega328P microchip. Operating voltage is 5 volts and input voltage is 7 to 20 volts. There are digital input-output pins which are 14 in number, out of which 6 can provide pulse width modulation. There is one UART. There are 6 analog input pins. DC current for 3.3 volt and 5 volt pins are provided. It contains flash memory 32 KB, of which 0.5 KB used by bootloader. SRAM is 2 KB, EEPROM is 1 KB, and a clock speed of 16 MHz is provided. Now our next component is pulse rate sensor. We have interfaced a pulse sensor with Arduino. The pulse sensor we are going to use is a plug and play heart rate sensor. This sensor is quite easy to use and operate. If we place our finger on top of the sensor, it will sense the heartbeat by measuring the change in light from the expansion of capillary blood vessels. Now we will look into pinout of the pulse sensor. The pulse rate sensor has 3 pins. They are ground, VCC and signal. There is also a LED in the center of this sensor module which helps in detecting the heartbeat. Below the LED there is a noise elimination circuitry which is supposed to keep away the noise from affecting the readings. Now I will explain the working of the pulse sensor. When a heartbeat occurs, blood is pumped through the human body and gets squeezed into the capillary tissue. The volume of this capillary tissue increases as a result of the heartbeat. But in between the heartbeats, which is the time between 2 consecutive heartbeats, the volume inside capillary tissue decreases. This change in volume between the heartbeats affects the amount of light that will transmit through these tissues. The change is very small, but we can measure it with the help of Arduino. The pulse sensor module has a light which helps in measuring the pulse rate. When we place the finger on the pulse sensor, the light reflects will change based on the volume of the blood inside the capillary blood vessel. During a heartbeat, the volume inside the capillary blood vessel will be high. These affects the reflection of the light, and the light reflected at the time of the heartbeat will be less compared to that of the time during which there is no heartbeat. The variation in light transmission and reflection can be obtained as a pulse from the output of pulse sensor. This pulse can be conditioned and measure heartbeat can be obtained as a heartbeat count. We have used 2 LEDs which are light emitting diode as the output signal, and a buzzer is also used. We have also used Wi-Fi module ESP8266. The ESP8266 Arduino compatible module is a low-cost Wi-Fi chip with full TCP/IP compatibilities. And the amazing thing is that this little board has a MCU, microcontroller unit, integrated, which gives the possibility to control input-output digital pins via simple and almost zero-code-like programming language. Now I will tell you about the connections. So the main sensor of the project, which is pulse rate sensor, is connected to the microcontroller, which is Arduino Uno. The ground is connected to the Arduino ground. The signal pin is connected to A0, and the VCC is connected to the 5 volts. The first LED is connected to the pin number 13, and the second LED is connected to pin number 10, and buzzer is connected to pin number 9. And all the components, which are LED 1, LED 2 and buzzer, all of them are having the same ground point. Apart from all this, our Wi-Fi ESP8266 is connected to it, in which TX and RX of this module is connected to TX and RX of the Arduino. One pin is given to the ground and 2 pins are given to 3.5 volt power supply. Now all the circuit is connected to the 5-volt power supply, which is taken from the source using the USB cable, which will be connected to the laptop. We have uploaded the code in the Atmega 328P chip using Arduino IDE software. In the Arduino IDE, we have used a library which is called as Pulse Sensor Playground. This library is used for pulse rate sensor. To take the pulse rate and convert it to BPM, which is beats per minute. In code, we have kept two thresholds, threshold number 1 and 2. Once our signal is fed in the microcontroller will send the signal and the condition will be checked. As per the condition, output will be seen. If the pulse rate is in the range, the LED 1, which is green light, will be glowing. And if the signal is not in the range of the threshold, then our second LED will glow and buzzer will be ringing, indicating the emergency signal. Now we have connected the Wi-Fi so that the data will be indicated in the cloud. We have used ThinkSpeak. ThinkSpeak is an IoT analyst platform service that allows you to aggregate, visualize, and analyze live data streams in the cloud. ThinkSpeak can perform online analysis and processing of data as it comes in. So our output data will be seen in the ThinkSpeak. Now I will demonstrate the working of the project. So this is a pulse rate sensor which I will place on my pulse, and we can see that green LED is glowing, indicating that my pulse rate is in the range. And as you can see, the data got stored in the ThinkSpeak. Now as you can see, when a person's pulse rate is not within the range, the LED and buzzers are giving the output signal indicating that there is an emergency and we need to send the help. Now as you can see, the data got stored in the ThinkSpeak cloud, indicating that there is a emergency. So this was a working demonstration of our project Smart Saviour device to avoid death in the swimming pool. Our prototype can be developed into a wristband in future implementations with more technologies applied. We can even use more sensors to get more accuracy in the results. We can even use GPS so that we can position the person who is wearing it. As mentioned earlier in the PPT, our prototype can be used in day-to-day life by children and people as well. The colleges and schools which provide swimming pools and swimming classes for the children can use this device as a safety measure. Even the entertainment industries where swimming pools are provided, they can use this as a safety measure. With this, I would like to conclude our project and say that our safety is in our hand and we should be careful with it. Thank you.